Okay, let's talk about your quiz. The first part said to simplify using distribution. And so you would have 7a times negative 2a. And a common error here was that a lot of people didn't put negative 14a squared. And then you also had to do 7a times 3. And 7a times 3 is 21a. So that was the other most common error there. Then this other distribution one, 3x times 4x, that's 12x squared. Actually, I'm going to write it down here. 12x squared. Then 3x times negative 5 is negative 15x. And then remember, now this 1 gets to multiply. 1 times 4x is 4x. And 1 times negative 5 is negative 5. Then you combine like terms, and you get 12x squared minus 11x minus 5. Then the next one was the greatest common factor of 6x squared and 5x. So if you're looking at 6x squared and 15x, and 15x, what's the most they have in common? What are the greatest things that are part of both of their factorizations? So 6 is 3 times 2, and 15 is 3 times 5. And I think most everyone got the 3. Well, x is x squared is x times x, and x is just plain old x. So what do they have in common? What's the same in both? They both have the same, at least one x. Do they have x squared in common? No, because the 15 just has x to the first power, not x squared. Okay, then 20a to the 5th b squared c, and the 18 a to the 8th b 9th c. So 20 and 18. If we think of the numbers that can multiply to be both 20 and 18, for 20 you think of like 2 and 10. 2 goes into 18, so they have that in common. 20 you think of 4 and 5. Neither one of those goes here, so far 2 is our biggest integer. In fact, that's all there is for 20. 20 and 1, 2 and 10, 4 and 5. So the only thing these two have in common as far as factors is the number 2. In other words, both of these can be divided by 2, but there's no bigger number that I could divide both of them by. Now, to get the greatest common factor, we want to know, what do they have that's the same? Do they both have at least a to the 5th power? Yeah, this one has a to the 5th. This one has extra a to the 8th, but it means their a to the 5th power, they both have. That's in common. This one has b to the 2nd power. Does this one have b to the 2nd power? Yeah, in fact, it has b to the 9th power, but this one doesn't. So the most that they have that's the same is b to the power of 2. This one has a c and this one has a c. That means they have that in common. That's going to be a very important concept coming up. All right, so now we're looking at this one, number 5, to see if it's linear or quadratic. So we look for first differences. This would be plus 5, and yep, looks like they're all plus 5. So that tells us that this is a linear function because the first differences are all equal. Then it wants to know the recursive equation. Well, definitely f of n equals f of n minus 1. This means if you want a new answer, you take the previous answer. So let's say I wanted f of 6. How would I get it? I would take 27 and I would add 5. This means take the previous answer, add 5. Previous answer plus rate of change. For our explicit equation, I'm just going to I'll use t's because that's what I used to do. So for t, it's the rate of change, so 5t. and then plus your initial value. Well, we don't have an initial value here because it starts at 1. So we have to consider, oh, if we worked our way back to 0, what would this be? You'd go backwards 5 minus 5, so it would be a 2. And then, hey, how could you check that? Well, does that equation work? Does 5t plus 2 get you the right answer? So let's just look at, for example, 3. If I did 3 times 5, so f of 3, if we're just checking our work here, is it 5 times 3 plus 2? 17? Yeah, it works. So that is correct. Okay, now I have this whole thing, and I want to know if it's linear or quadratic. I think I'm going to look at the table first. Difference here is 20, and that's a plus 20. And then here it looks like it's 24, and here it's 28. I'm assuming you did that subtraction on your own. Then the second differences are 4. So this is definitely quadratic because the second differences are all equal. So a recursive for a quadratic, f of n equals f of n minus 1 plus, then you need the first difference and an n, so 4n, and then plus or minus some mystery number. And the best way to find that mystery number is just by plugging in. A lot of you tried to plug in f of 2, and that doesn't work because you need a previous answer which you don't have. So I would have used f of 3. And the previous answer before 3 minus 1 is 2, f of 2 would have been 28 plus 4n, that's 4 times 3. And then plus some other thing, and weirdly we already know the answer. We know that f of 3 is 48. So we're trying to figure out what would have to go here to make this work. So again, this 28 is f of 3 minus 1, f of 2, which I got from here. 28 plus 12 is 40, plus blank equals 48. So my missing number is plus 8, because 40 plus 8 equals 48. So this is the recursive equation. Make sure you have a plus sign right here, 4n, and a plus 8. Explicit. So this is one of those situations where looking at the rectangles is going to make it easier. So if I notice I have term 2, 3, 4, 5. Well, 2 times 2 is 4. That makes me think, okay, so this n is 2. N is 3 here. Oh, 3 times 2 is 6. N is 4 here. 4 times 2 is 8. So I bet the side is always 2n. Right? 2 times the term number. 2 times the term number. Oh, term 5? Yeah, 2 times the term number. So I already know down here that it's 2n, whoops, that it's 2n times something. How can I look at the top? Oh, like, 5 times 2, is it 2n again? No. I gotta go 4. N is 4, how do I make that a 9? N is 3, how do I make that an 8? Oh, it looks like the difference is 5, huh? So this would be n. If n was 2, if n were 2, I would need to go plus 5 to get 7. Does that work here? N is 3, so does 8 equal 3 plus 5? Yeah, we got it. N plus 5 is on top. And so then you got 2n, f of n equals 2n times n plus 5. Then you were asked to find f of 6. You could have done it either way because you have both equations here. You have the recursive and the explicit. I would use the explicit probably, so it'll be 2n, which is 2 times 6. Then n plus 5, so that's 6 plus 5. So I just plugged in. And we're supposed to do the parentheses first, so that's 11. And that's 2 times 6, so I'll just do 2 times 6 times 11. 2 times 6 is 12. Times 11 is 132. And that's it. I also want to point out that I know I didn't do the subtraction by hand on some of these difficult ones, but for me to talk through every problem took 10 minutes, and you had 20 minutes on your quiz. So I hope this was helpful in helping you correct this. For the next couple of weeks, make sure you come and see me in tutoring if you're still struggling with any of these.